Hi guys, so today we're going to go over permutations and combinations, but before we do, just touching up on independent and conditional probability, which was in the last section. We're going to go over the multiplication rule for independent events, meaning two events that can happen independently from one another. So just make sure that you have this down in blue. And the first two examples are examples of two independent events. So for instance, if a coin is flipped twice, what is the probability of getting heads on both the first and the second flip? So when you flip a coin, the second flip does not depend on what happens on the first flip. So we have the first and the second time we flip the coin. So total would be the denominator. There's two options. You have heads or tails. And the probability of getting heads, well, you have one shot there. The other side is tails. And the same thing for the second event. It would be heads. You have one of them over a possibility of two options, which would be the heads and tails. And then from there, notice that you're multiplying those two events, which would give you, multiplying fractions, we go straight across. That would give you 1 over 4. So from fractions to decimal, a fraction is nothing more than just the top divided by the bottom, numerator divided by the denominator. So 1 divided by 4 would give you 0.25. Think quarters, 1 out of 4 quarters. And then to go from decimal to percentage, you're just going to move the decimal over twice. So think about your alphabet. D to P, you move the decimal over twice that way to go from decimal to percentage. And then think about percentage to decimal, you would move the decimal twice that way. Just kind of a little fun fact. You don't have to know that, but just saying. So the probability of getting both heads on the first and second flip would be 25%. So same thing here. You have a six-sided dice. Sorry, spell check here. Is rolled twice, just the dice, not diced, is rolled twice. What is the probability of rolling a 5 on the first attempt? So let's note out the first attempt. If you look at a dice, there's 1 5 on it, and there's a total of 6 possibilities. So 5 on the first attempt, and on the second attempt, a 6 on the second attempt. So if you look at the dice, there's only one side that has 6 dots on there out of a total of 6 different possibilities. And again, we'll multiply the two. And we multiply straight across, which would give me 1 over 36. Again, divide 1 divided by 36, and just rounding it, it would give you about 0.028. So again, to actually write the decimal value, you would move it over twice from this decimal 1, 2, which would give you 2.8%. Okay, now from here, make sure that you kind of write this down because we're going to go into the examples for combinations and permutations. So combinations is the number of arrangement of possible combinations, but it happens in any random order. Like there's no particular order, no first, second, third, no president, vice president, treasurer. There's no specific order. Whereas permutation, the arrangement of possibilities will be in a particular order. Just so you know, I'm going to show you how to calculate these on your scientific calculator, but in case you do actually want to calculate it by hand, these are the formulas, and it would just be the total number. Sorry, that's not a great color. N would be the total number, and R would be the number of groups or people or whatever you're taking. So if you're taking a group of 5 out of a total of 15. So R would be the smaller value that you're combining into the groups. And just factorial. Factorial means you're multiplying that number by every positive number before it. So for instance, if I were to ask 4 factorial, what that means, that would mean 4 times 3 times 2 times 1. That's all factorial means is you're multiplying that number times every positive number before it. Again, I'm going to show you how to input this on a scientific calculator, so you don't have to know it, but just fun fact. All right, so moving forward. So there's 30 players trying out for a team. They're separated into groups. How many different groups of 5 can be made? Notice that They are not going to be separated in specific groups of 5, like captain, co-captain, I don't know, anything like that. So this would be a combination. So this would be 30 total players, and you're trying to group them in 5. So we should note from the last slide, NCR. N is the total, 5 is the number of groups we're trying to make, and then you could plug it into this formula, which would just be 30 factorial over 5 factorial times 30 minus 5, and then take the factorial of it. But that's a lot of work, because 30 factorial means you're multiplying 30 times 29 times 28 all the way to 1. So rather than actually do that, we have a little video here. Make sure you have your scientific calculator out. So we're going to take 30 PRB, go to NCR, equals, and then press 5 and equals. And that should give you 142,506. So for the next problem, notice that there are 10 people in a line. In how many ways can a 3-person line be formed? So someone has to be first, someone has to be second, someone has to be third. So this would be a permutation. Total is 10. We're trying to put 3 in a line, 1, 2, 3. So they're in a certain order, first, second, third. Just like president, vice president, treasurer. Those type of things would be a permutation because it's in a specific order. So again, you could put this into the formula, or I'm going to show you really quickly how to input this into the calculator. So again, you're going to type 10. PRB means probability, and this time you have NPR right